Hi Year 7, welcome to this week's science video. Again, this is our last week before a half term. How exciting! This week's focus is a physics focus, and our scientist is Marie Curie, which some of you will already know about. Fascinating and amazing woman. I hope you enjoy finding out about her. Our focus, as I said, is physics. We're looking at energy, we're looking at waves, specifically sound waves. So let's get started with, as always, investigation task 1. So task 1 investigations, as always, there's 2 you can choose from, or you can do both of them. Now it says, see if you've got 2 balls of different sizes, but by all means explore. Try 2 the same size. This is your opportunity to investigate. The instructions, as always, are provided for you, and it says put one ball on top of the other ball, and you're simply going to put one hand under the bottom ball, hold the top one, and then let go. Now I'm not going to let you see what happens on the ground. Some of you might know, but you drop them together and something will happen to the balls. I want you to investigate different sizes, different types, see what you find out. Who can make the second ball fly the highest, and why do you think it happens? Second one involves a balloon. If you have one, you need to blow the balloon up, but you can blow it with different volumes of gas in it, different volumes of air. Don't tie it, because then you can change the volume of air inside it, and you just got to put the balloon to your ear, and you're going to tap the other side. Now this amplifies the sound, and as we talk about later on in the task and in the information you've been given, it's because the particles inside here are squashed together. All those gas particles, the air in here, the particles are trying to spread out, but they're being compressed and held in this balloon when they want to be getting out. So they're much closer together than they are in the air around us. Because they're closer together, they pass on the sound vibrations, the sound waves much better. So have an explore, then let it out, funny noises, and then blow it up, make really big balloon. Is the loud quieter or louder as there's more or less air? So that's what you've got to do for these investigations. Have fun!
Revealing Mrs. Blomley.
Right, assistants are getting carried away now. Right, task 2, as always, is finding out a little bit about this week's scientist. And this week is, as we said, is Marie Curie. Now, Marie was actually born Maria, but she later adopted the French spelling of Marie Curie. She is very much remembered for discovery of radium and polonium. See if you can find these on the periodic table. So she discovered these and worked lots with her husband. She did lots of work in radiology, and in fact it was her that was responsible for X-rays. She had the little petit curies, these little vans, little trucks that would go to soldiers, etc., wounded soldiers in the First World War, and she would be able to X-ray them where they were and find out if they had broken anything. So incredible in 1914, incredible. And she's also very well known, as I'm sure many of you know, for her work in the field of cancer and cancer treatments. So an amazing woman. Please enjoy finding out about her and answer the questions at the back of the pack. Good luck. So task 3 is the explanation part. This is where you're going to put into practice things you already know and things you're going to learn from this video and from looking back through your book. Now, I've not provided all of the answers in this video because you've got some in your science books already. You've done sound in school already. Now, when you think about sound, the particular wave that sound passes by means that the wave doesn't travel like this. Sound doesn't travel like this. Light travels like this. But sound travels by the particles where the sound is produced. They squash together, and then the particles spread out. Then they squash together, then they spread out. Then they squash together, then they spread out. When we did this in class, we often show a slinky. If you hold a slinky and push it from side to side, you'll see the slinky passes the vibrations on, and that's how sound waves travel. The particles pass on the vibrations so that we can hear it. So when you're thinking about sound, and then it's this passing of areas of compression of particles, and it's what's called rarefaction. So the particles pass it on, they squash together, and they spread on, they pass on this vibration. Have a think about the 3 states of matter. So let's have a look at these. So we've got the particles of a solid in a very tightly packed, very regular arrangement. You can see the rows and columns, and they're all touching, they're all very close to each other. Then we have the particles of a liquid. Now they're also touching, they're also closely packed, but they're not in a regular arrangement. So if this one here was to vibrate, yes, it can make these 2 vibrate, but it's not a clearly ordered pattern of vibrations. Whereas here, if these all vibrate, they vibrate, which means they vibrate, and it passes on very, very quickly. Then we've got the particles of a gas, and they are very far apart, so they're going to be taking a little bit of time for this to vibrate and then bump into this one, and this to vibrate and bump into something else. So have a think about, for your first explanation of why does sound travel fastest in solids, have a think of the particle arrangement and the passing on of these vibrations. Right, so on this one, we're looking at energy. So we're talking about the conservation of energy. What is conservation of energy, and why is some energy lost, or we consider it lost? Well, if we start having to think about the different types of energy, we have kinetic energy, movement, we have thermal energy, we have sound energy, we have light energy, we have electrical energy, we have elastic energy, we have chemical potential energy, all these different forms of energy. But we can't lose them, they just get transferred to a different form of energy. So if I eat a bit of this delicious chocolate brownie, delicious if I do say so myself, we've baked it this week. If I eat a bit of this, in this brownie there's chemical potential energy right now. If I eat it, I will then digest it, and I will transfer this energy to kinetic energy, because I can move, thermal energy, because it keeps me warm. I get warm from the process of respiration. And if I sit in this car all day and not do enough exercise, it will get stored as lovely fat cells as more chemical potential energy ready to use at a later date. So that's the first example of this transfer. The energy gets conserved. If you add up all of those energies, it would be the same as the amount of energy in that brownie. Another example is the car. I'll eat that later. Another example is the car. So if I drive my car, there I am, and if I'm driving along, there's chemical potential energy in my car. I then drive the car, and I will transfer that energy into kinetic energy because I drive along the road, and I will transfer it to thermal energy because I can feel my car get warm, and you can hear my car. So there's also sound energy. So if you add up all of those energies, it's the same amount of energy as is in my petrol. Okay, so another example would be bouncing a ball. Anytime you lift something above the ground, you have stores of gravitational potential energy. Because it's above the ground, there's this force of gravity, which means if I let it go, it will move and fall to the ground. So this starts off as gravitational potential energy. When I let it go, it will move through the air. Now as it brushes past all the air particles, it transfers some energy in the form of thermal energy because there's friction between the ball and the air particles. So it will transfer some of its gravitational potential energy to the air particles. It will then touch the ground, and because there's friction between the ball and the ground and it's rubbing together, there will be a transfer of thermal energy. So it will be kinetic energy because it's falling, that's movement, and thermal energy. More thermal energy. The ball will then reach the ground, and there may be a slight depression in the ball depending on what type of ball it is. So you may actually give the ball some elastic potential energy. It will bounce and then come back up as kinetic energy, back up to the top as gravitational potential energy. So there's lots of transfers of energy, but the total energy will match the gravitational potential energy at the start. We can't destroy energy, we can't create it. So of our examples, here is a little note of what we've just talked about. So eating, chemical potential energy is transferred to these three forms. Driving your car, we start with chemical potential energy in the fuel, and we end up transferring it to these three. And then bouncing a ball, you start off with gravitational potential, and it gets transferred to those three, possibly elastic potential. All of these final energies will add up to the energy at the start. That's the conservation of energy. Right, task 4, as always, is the video. Just watch the video, make some notes. It's all about how you hear. So this little kitten hears because sound hits its little ear, it goes inside, vibrates, passes the vibrations on through the little bones in his ear, and then that gets transferred as signals to the brain. Have a look at the video, make your own notes. It's goodbye from Tweety Pie. This is going to be my sister's cat. It's goodbye from me. Have a fantastic week.